So today, as Masa said, we're talking about Arbitrum Orbit. This session is a bit different from the previous about stylus. Like here, it's kind of non-interactive workshop. So me and Jason show you uh, like how to deploy your Orbit chain. So, like, I'll start with defining what is Orbit, like explaining what is Orbit a bit, then show you how you can deploy your Orbit chain like in different settings, and I'll pass the stage to Jason after that to show you how you can like do um, like super technical things to like deploy your chain. So let's start. As you know, like we have two chains right now, two Arbitrum chains, Arbitrum One and Nova, which like serves million, like hundred thousands of applications and like millions of users. But applications decided to go one step further and deploy their chains, and like each of them may have their own goals for doing that. Uh, what is Arbitrum Orbit chain look like? Currently, we have two main set of Arbitrum Orbit chains, like L3 Orbit chains, which you can deploy. Currently, you can deploy it permissionlessly, and like the code base is open source, so you can like do whatever changes you want to do on the code base and like deploy your chain permissionlessly. Also, you can like on L3 setup, you would deploy your chain on L2, like either Nova or Arp1 chain. But like we have another case which is L2 Orbit chain. It's very similar to Arbitrum One and Nova chain, but like this could be your chain. So right now you need permission from Arbitrum DAO, but we're working on like with Arbitrum Foundation to make it permissionless, maybe in the near future. But like the difference is you would settle on Ethereum L1. So L3 Orbit would be similar to that. Like you have Orbit chains settle to L2, and like as you know, like L2s would settle on L1, but L2s would be very similar to like L2 orbits would be similar to current L2 Arbitrum chains. Like we have Orbit chains, uh, which would settle to L1, like Ethereum mainnet. So Arbitrum Orbit is uh, like you would deploy Arbitrum rollup smart contracts to L2 chain or like Ethereum chain for sure, and you would use Arbitrum node software with like minimal changes to handle that chain. So why you want to have your chain? Like we have lots of uh, like reasons that people would want to deploy their chain. One of them is like um, Arbitrum One. Like in Arbitrum One or Arbitrum Nova, we try to optimize like the chain for Ethereum, but like for Orbit chain, you can like do whatever you want to do. Like and like for example, some of the changes you can do like to a state transition function could be like adding EIPs that people are not agreeing to add it to Ethereum right now, changing like access control thing, like or adding new, for example, cryptography like libraries as precompiled, for example, like this one, which would like give you lots of options. uh, Also, the other reason that you may need to you may want to like have your own chain is gas price reliability. It's like on Arbitrum chains or like L1 chains, you would compete with other applications and users of that application for the block space. But if you have your chain, then like you can predict it, because like you know about your users, and only your users would use your chain, and not the other applications user. So like it would, unlock the room for you to like somehow even cover users fees, because you can predict things out there. Also, like the other thing is, you can customize protocol logic as well. Like for example, adding support for some other ways of data availability layers. For example, as you may know, we currently added Celestia as the data availability layer to Arbitrum Orbits. Also, you can do lots of crazy things, like for example, like having your own governance system and model, or like introducing like new forms of cross-chain modification, cross-chain communication, or like do lots of amazing things. Like one of them would be presented by Jason at the end. So as I said, like we have L2 and L3 orbit chains, but we would recommend having L3 chains. And the reasons that we have is, like for L3 chains, we have like faster finality. And like the reason is, our batch poster, which posts batches back to like the parent chain, like for L3s, it would be L2. For L2 orbit chain, it would be L1. And like it's much cheaper to send batches to L2, so you can do it more frequently, and it would help you to like to settle your transactions much faster. So finality speed, which is super important, is much faster on L3s, because like it's cost efficient to send batches more frequently. Also, this is super important for example, like gaming. Your users need to bridge funds to your chain, right? And like if you are an L2 chain, then like your customers need to grab some ETH or any asset on L1, then bridge it to L2. But like if you have L3 chain, then like your users need to have the money on L2 and then bridge it to L3, which is much cheaper. So like L3s are great on that case as well. So uh, now the main question we want to answer in this talk would be how we want to how you can deploy your chain. And we have a toy tool right now to give you some example how you can set up a chain completely, set up an Orbit chain. And if you go to arbitrum.io, you can see here. And like if you deploy Orbit chain, you would see this page. So we have two main setups for your Orbit chain: rollup or AnyTrust. These are two main technologies that we have on Arbitrum stacks. Like for example, as a rollup chain, we have like Arbitrum One. It's a rollup, but for any trust chain, we have Arbitrum Nova. I will discuss like the differences a bit. But other than these two, we recently added a new type of chain which we don't have on mainnet. It's just for Orbit chains, and it's amazing. It's gas fee token networks, in which you don't need to have any ETH on your pocket. You need to just like like your users just need to have your own token on that network, and they can pay all the fees with that token as well. Like no need for any other tokens for like or ETH for token payments. We will get back to these like later in the slides. But for roll-up orbits, so as like to remember, we have two types: roll-up and AnyTrust orbits. The roll-up orbit stack is something similar to this. Like I don't want to go into details, but just like the main point I want to clarify is, like as I said, like sequencer on Arbitrum stack would batch and compress all the transactions, send them to the parent chain. Like for L3 chains, it would be settled to L2, right? So sequencer would batch and compress transactions, send them L2 chain. And like this is the most like fee that you're paying, because it's much more expensive to send batches to uh, like parent chain, like than like working with the like with your Orbit chain. So like the most of the cost that you're paying is this part for transactions. But on any trust, we tackle this problem, like this issue, like of because like to reduce the amount of fees that you need to pay. So what we did is, like, instead of sequencer batching and compressing the transaction and send the whole that data to L2 chain, we've added a way to, like, you can define data availability committee that have some members, and these members attest that, like, they keep data of those transactions, and just send that attestation each time to L2 chain, which is like a kind of aggregated BLS signature. So in this way we reduce the fees a lot. Like, but somehow you can see, like, sacrificing security a bit on data availability part. So for sure, AnyTrust is much cheaper. On AnyTrust, you need to rely on data availability committee for data availability. And but like, it's good for different use cases. Like, AnyTrust is better for gaming and social media, but Rollup would be better for DeFi and financial apps, because it has for sure less trusted points, and it would be good to keep assets on the chain. So, like, now what is Orbit and what is AnyTrust. Let's jump into our tool and see how you can deploy a chain with our tool, with this UI tool. So, like, let's choose rollup mode, and when you click on next, you would see this. Like, this is the minimum set of configuration we currently have on our UI, but for sure, like, there are lots of other configurable parameters which we decided not to add for now, but we will do it for sure in the future. Also, there are another ways that you can easily set up these configuration, but for this, like, params, let's discuss what are they. Like, chain ID for sure is chain ID for your chain, chain name, challenge period block. It's amazing, like, parameter which like, it shows the like the period that like, your chain needs time um, to be finalized, or in another case, that it's the time that validators have time to dispute any like, any proposed block by other validators. Currently on Arbitrum 1 and Nova, it's 7 days, but like, based on your security setup, you can reduce it. Also, that's a great case. Also, there is stake token, which currently it's ETH. Like, validators who validate the chain needs to stake to have skin in the game, for sure, to be sure that, like, if they act like badly, where you can, yeah, like, punish them. And also, like, the amount they need to stake and the owner, and, like, forget about this native token for now. As you can see, like, it's green gray box, so you can change it for this setup. We will get back to it later. After, like, doing that configuration, you need to set up your validators for sure, like, and also batch poster, which we discussed before, like the agent that that is responsible for sending batches to parent chain. And then you need to review the whole data you provided, and, like, deploy the chain with, like, sending the transaction to parent chain. And after that, you would see these, like, two configuration files that you would have at the end, one for running the node, the other one for L3 configuration. um, you need to download these two, and I will let you know, like, how you need to like use these two files, but it would um, contain like all the things that you need for further steps. So till this point, what we did is pre-configuring the chain by setting the L2 configs, the configs that I show you, also setting validators, setting batch posters. Like by doing that, we pre-config the chain. Then we deployed all core contracts on L2, like bridge contract, invoice contract, roll-up contract, etc. And also, like we created the node config file and also L3 config files for initiating your orbit chain, your L3 orbit chain. And what's left here is so you need to initiate your chain with the node config that you downloaded. Also, you need to fund validator and batch poster so they can operate as they need to, because like they need to send transaction for sure, and they need some amount of money on their pocket for like first transactions at least. Also, you need to bridge some funds to L3 so that you can deploy like contracts there. You can configure things there and test. Uh, Also, you need to like deploy your token bridge contracts on L2 and L3. And also configure the L3 part, your L3 chain as well. So let's start with initiating the chain with node config that you downloaded. So we have set up a script which we wrote and make it much easy for you to like handle all these five things. But for the first one, which is initiating the chain, it would be like you should like put those two config files in this folder. Like first of all, for sure, you need to like clone this repo, and like after cloning that, you need to like put those two files onto config folder, and I mean these two files that you downloaded. And then as you can see here, we have a Docker compose written, which makes it much easy for you to just like use this command to run that Docker compose. And it would like it's containing lots of like different uh, Docker commands, which like it will uh, generate the uh, like all the things that you need for L3, like initiating things there. And as you can see, like it would run this. So at the end on your Docker, you can see like these three uh, like Dockers that are running. One of them for sure is Nitronode, which is the core logic of the system. Like it's similar to like Yeth for Arbitrum. Also, what we do like on that Docker Compose is like we're running Block Scout instance for you as well. So when you set up your chain, like automatically we give you an Explorer, which is an instance of Block Scout, and you can have it on port 4000. So like you have your chain now, and you have like the your Explorer. What about the other ones, like the other four things that left? So on the setup script uh, tool that we wrote, we have like we wrote other scripts as well to do all these four things, like funding like the validator batch poster, bridging funds to L3, deploying token bridge for you, and configure your L3. And like we use all these different scripts on one script named setup.ts, which run like all of them one by one. And you can run it with this command, like putting your private key here. Also, like we currently just support chain deployment on L2 Sepolia, like our Arbitrum Sepolia testnet. So L2 RPC URL should be this, and also like for sure L3 RPC would be, as we said before, it's localhost port for 8449, which is like an RPC to your Nitro node, and yarn run setup, which would like run the script, do all the things that we discussed, and now you have your chain up and running. And also like, so as I said, like you have RPC with this, you can add it everywhere you want, like add it, for example, on your MetaMask for testing, etc. This is the RPC. Also, you have Block Explorer, which is the like an instance of Block Scout and Disport. Also, we will give you a file, like output file on that setup script named output info JSON, which is like which gives you all like chain configs that you configured your chain, also all core contracts like inbox contract, sequencer inbox contract, etc., and also token bridge contracts that you recently set up. So all done, you like deployed your roll up chain. But what about any trust chain? Like I can say like 90% of the things are similar to Orbit, to roll up orbits, but like I just let you know what are the differences. First of all, when you like click next, like you can see configuration. This one is like white box right now. I would get back to it. What is native token? But like for a simple any trust chain, you don't need to change it. Like all the things are the same with rollup. The other part that is different is key set. So you need to set up your key set, and why you need that is like, if you remember here, I said that you need to set up your chain with like data availability committee. So like, and as you remember, like I said that for each batches, like these members need to uh, somehow attest that they have the data and they keep the data, and like do some kind of aggregated BLS signature, send it back to L2. So L2 should know about these members, and like somehow their keys, like their public keys, to be sure that like they signed it well and like it's correct, as a thumb up. So that this key set represents those members somehow. So like when you set up your chain and like having all different members, you need to set the key set here, and you can see like what is key set and these kind of things and how to set it up more on our docs as well. But like for this tool, as I said, like it's kind of a toy tool. We just have one member for DAG, which has zero private key, to make it much easier for users to set it up. And this like default key set is for that member. Also, when you initiate the chain, all things are the same with rollup chain, but like one difference you can see, that server. So this dash server is a server which handles like the members, and I said, as I said, like because we have just one member here, like we have just one dash server, and dash server means data availability server. Is like each member of data availability committee. So like to summarize all the things, I described what is Orbit. I explained the toy tool and also a script that we have to set up your local chain with minimum setup like configs, and like you can test it out. With that, you can also, if you want to like do any changes, you can see like code bases of these two as well. But what about you if you want to like develop your chain much professionally? like changing like lots of things, like having like changing more configurable params, etc., etc. So we recently announced Arbitrum Orbit SDK, which is kind of like V0 for now. It's just handling the deployment, not configuration yet. But we will add like new features soon to it. And like if you go to our GitHub and like search for Arbitrum Orbit SDK, you can find it. Um, so because like it's just for deployment right now, I won't get into detail of it, and like because of for sure limited time. But the best way if you want to like start with Arbitrum SDK is going to example folder. Like for sure we have different scripts here doing lots of different things, but at the end you need to like deploy your chain, right? You can see like how to deploy different chain setups here. Like for example, like custom fee token, like this is gas fee token for sure, with like deterministic factory or regular. If on like you can see different chain setups example with or Arbitrum SDK here. So other than that, like the most professional way that you can like set up your Orbit chain is not just changing the customizable parameters. So like to customize your chain, you can have like two ways: changing configurable parameters, which like have a minimum set of them here, but there are lots of other things that can be configured easily with like just like changing one thing on the code for setup, or like after setup like calling a setter function to change that. But like, and as I said, like we will have it soon on Arbitrum SDK. But other than that, uh, you can change the code base. Like you can do lots of things, like changing the logic of protocol, changing state transition function, etc. And like for example, changing state transition function or adding a new precompile, doing something that you need like specifically for your chain and want to be as a precompile. And yeah, as an example, we have adding new precompile, which my colleague Jason would explain that to you. Jason,
Okay, thank you.
mic is yours.
Could you? Okay, nice. Okay, thank you, Mehdi. And now I will introduce you how to customize your chain's behavior, such as the pre-compare contracts. So before we begin, I will introduce you about our state transition function, because if you want to change your pre-compare contract, you need to do something, maybe break your state transition function, because the blockchain is one single thread VM. So if you change something, it may break the outcome of the state. So so here is how our state transaction function works. It will collect the transaction from the sequencer. So if you want to collect the transaction from the sequencer, you have two ways. One way is to read L1 inbox. This is a contract on the parent chain of your orbit. So another way is your sequencer will feed out some feed informations, and those information has some transaction sequencer, and then you can read it. So after you read it, you need to put them into your state transaction function, and then it will execute your transaction and output the L2 blocks, and also it will do something change to update your state. Okay, so from the from overview, you can say if you have ever run our lateral load, you will say we have not only gas in the crew of and also we have RBOS and also the load of functionality. So for the load of functionality is some RPC which can provide you something about our some information about our load and also some GraphQL functionalities. So if you want to do something change to those things, it won't break your STF because it won't related to your state. So but for other things, such as something such as gas calculation or other things, it might do something change to your gas calculation. Then you need to do something maybe in RBOS, also maybe in good gas query. Also, okay. So if you want to change your code in your lateral code base, so what change will not affect the STF is the something. For example, if you want to add a new RPC method and this method is read only, so you can just add it. It won't do anything uh to do anything to affect other transaction. So you don't need to bother anything. So you just add it to our ledger code base is okay. So for another thing is if you want to change the order policy by the sequencer, you can also change it. Those are not those also will not affect our state transaction function is because the state transaction function will pick up some transaction which is already ordered. So if you before you put your transaction into the STF, you just change the order way of your uh sequencer is okay. So you can just edit it because for now for Arbitrum 1 and for Arbitrum Nova we use the way to first come and first serve. So if you want to change it in your sequencer, you want to charge some tips, or you want to put someone's transaction more faster, you can just edit. So what thing will change will affect the STF is if you want to add some new UMOP code or other pre-compares, you need to modify that because once a contract deployed on Arbitrum and if you have a new UMOP code, the old one won't know this OP code, so it might reject your transaction. And for other things, if you deploy a new pre-compare contracts and called by other on-chain contracts, and but some other nodes don't know the new STF, it will break their validations. And also, if you don't let L1 or your parent chain rollups contracts know your new STF root, uh, uh, on the after it it do something about the fault proof. It will also don't know your new pre-compare, so it might break your fault proof. This is super important. So if you ever want to add those things, you need to change the STF. And also another way is to rewarding the deploy of a smart contract. You also need to do something change to your STF because it's related to the gas calculation. And also if you want to do more like for some users transaction you don't want to charge their gas cost, you can also change it by add a hook. Like if someone send a transaction to your load, you will execute their transaction first and then refund all all their gas cost back to their contract. So it will equal to you don't charge anything to charge any gas cost from the users. Those are some interesting customizations you might need, you might want to do to your load. So okay, let's go to the next step. If you Today I will just pick up one example about the edit your pre-compare as an example. So if you want to edit your pre-compare, first thing is you need to open a existing pre-compares. For the step, I will introduce you the code later. And then when after you open your existing pre-compare codes, you can create new methods or edit some existing methods there. And then because the pre-compare is a contract which can be called by other on-chain contract, so you need to let other contracts know your ABI. So you also need to update your pre-compare contracts ABI. And then is the most important thing is you need to compare your edit natural source code, and then after your comparison, you will get the new Watson module root. The Watson module root, you need to send it later to our ZooOps contract to make sure our fault-proof system can works normally. So after that, all thing is done, and you can run your new load. So what about if you want to if you don't want to edit your existing pre-compare, rather than you want to add a new pre-compare? So the most different thing is the first three step. The one step is you don't need to open an existing pre-compare, but you just need to create a pre-compare file under our pre-compare directory, and then also continue to create the contract ABI. After that, just register your pre-compare. So how to do this, I will show you on the code. First, this example is to how to add your new pre-compare contract. So first of all, we for this example, I will add a new RB high as an example. So you can say in the pre-compares directory, and I created a new RB high dot go as our new pre-compare contracts file. And in this file, you need to add two things. One is the structure. The structure is you need to put your address information here, but just need to put the address field. We will fill this out on the later process, and then you can add your function here. Because this is just an example, so we just use the simplest, the easiest way to edit. So it's just we just add a new say hi function, and this function will just simply return a hi string. So after that you created your new pre-compare contract, you need to register it. So if you want to register it, you need to go to the precompare.go file under the precompares directory. So when you open that file, you will see there is a function named precompares, and so so you need to add this line, which is insert your new pre-compares here. So after this, you can finally register your pre-compare, and after that, you need to also register your new ABI, which I told you before, because you need to let other contracts know what your contract is and how to call your contract. So you need to put your ABI here, and you need to make sure your ABI here, your function name here is the same to what you defined before. So our goal, so when you pre-compare, so you compare our goal natural source code, it will recognize this function and then matching them together. So after that, you can just build your Docker, and then after you build the Docker will, after you compare your lateral source code, and it will calculate the new Watson module root, which you will need later. So how to build your Docker is super simple. Just input this command is okay. Just make Docker, and then it will compare it. It may take some time. So after that, you can run this Docker, run this, and it will output your new Watson module root. So how to register your Watson module root is here. This file is node config file, which you will get it after you create your new orbit chain. Also, this is what what Mehdi showed before. So open your node config file and find two contract address, which one is the rollups contract address and another is upgrade executor. So then you need to call the upgrade executor, and you need to find this contract execute call. Then for the execute call, you just need to input the first line is msg dot warning. You don't need to input msg dot warning, so you just set a 0 here is okay. And the next is target. The target is your rollups contract, which you can pick up here. And then the target core data. The target core data, the first 4 bytes is this one, and the later 20 and the later 32 bytes is your new Watson module rate, which you generated at the last step. So after you write it, you can check it where your rollups contract by just call the Watson module root. So it will output your new Watson module root here, and you can compare it if it's same as the result you get it here. So if it's same, so congratulations, you already edited your rollups contract to know your new natural loads logic. So after that, you can just run your Docker, and this is what Mehdi already introduced you before. And after you run your Docker, you just need to call this contract. So this address is stated when you register your contract here. So when you register the contract here, uh, you need to write down your new pre-compared address here. Here we just use the 11A as an example. So for here, you just need to call the contract address with 0x11A, and then we use the foundry cast to do this. So after you did do this, you will see our expected result, which you defined here. It's just a simple high output. So okay, this is our simple example of how to add your new pre-compare and how to register your new STF to our jobs contract. Okay, so for more information about this, you can go to our uh, docs website. It will show you more information. And also, because I just gave you a simple example because of the time limit, so we have others way to edit your pre-compare. Also, you can add some guess calculation to your pre-compares. Also, you can add the event logs to your pre-compares. Those are the links, and I will send in the comments later. Okay, this is how to customize your Orbit chain. Thank you. If you have any question, you can just put your question in the comments.
Awesome. Thank you very much to both Mehdi and Jason. It was a very great and comprehensive introduction and how to launch an Orbit chain and, of course, customize precompile. So we'll open the floor for questions from the audience. If there's anything, guys, folks, you can put it in the chat. Otherwise, I'll go ahead and ask some questions myself. Okay, so welcome, Matt. You were not here when we initially began, so yeah, GM. So the question is, either of you can take it. What do you guys think about interoperability or cross-chain messaging between L2 and L3 chains? How can teams and people think about that? And can you tell me if there's any option available for developers right now?
That's a good question. Yeah, happy to take that. And hey, guys, hope it's been a fun conversation so far. Yeah, so obviously with a lot of chains launching, and when you have multiple chains, cross-chain messaging becomes even more of a focus for teams. And we're definitely seeing this question come up a lot with folks working on Orbit. I think today there definitely are solutions available. There are kind of different cross-chain messaging solutions available at the application layer using kind of relay infrastructure. So there are a bunch of different protocols popping up. Chainlink has one. There's a group called Hyperlane working on some other relaying infrastructure. Connext has generalized cross-chain messaging. And a lot of teams are kind of working with these projects to enable those on their Orbit chains, and also the rollups as a service teams kind of work on direct integrations for Orbit chains. At the protocol layer, actually, one thing that's going to be interesting coming at some point soon, and we've talked a little bit about this, is kind of what we call fast confirmations. So for any trust chains that use the data availability committee, they can rely on those same committee members to confirm execution state a lot more quickly than the current challenge period, that's 7 days. So this isn't going to be something that kind of reduces confirmation times to seconds, but it'll reduce things down from a week to minutes, which for some teams is going to be a big unlock. So there are different ways to think about this. I think the cross-chain messaging solutions that are used for fast bridging kind of support our technology out of the box today and work with all Arbitrum chains, though there are some requirements around having liquidity, having the right contracts, having the relaying infrastructure set up. And so we'd encourage you to kind of talk with each of those teams if you're interested in working on implementing something like this for your chain. Hopefully that's helpful.
Yeah, of course. Amazing. Thank you. So both Mehdi and Jason walked us through the technical perspective of the Orbit chain, but from the product point of view, Matt, can you talk about what problems do these L2, L3 chains solve?
Yeah, sure. So I don't want to, repeat things too much. Hopefully this isn't. I think there's two main things that we are kind of seeing. Originally the goal with Orbit from an ecosystem perspective is to kind of give teams the permissionless path to launch their own chain and kind of giving them flexibility. So one big kind of general pattern, and this is why Jason was kind of talking a lot about adding custom precompiles, is flexibility with the core protocol. Some teams have certain customizations, whether that be kind of they want to reference a database with every transaction, or they want to do some kind of more complex cryptographic operation more frequently at the chain level. Optimizing their core protocol or the state transition function is something that a lot of teams have become interested in and are experimenting with. So it's much easier to do that when you are maintaining your own chain, as opposed to having to go through, say, like a larger governance process, or trying to do it at the application layer. It just might make sense for some teams to be able to make those changes at the protocol level. And so launching a chain is kind of the only way to do that. And on a related note, the flexibility around kind of the data availability layer you're posting to, kind of the sequencer, maybe the ordering mechanism, or things that people are exploring, and having the flexibility to choose what those are is only something that can be done if you are kind of operating the chain, or at least maybe your community is as well. The other thing that we're kind of seeing a lot of interest in is, when you operate a chain and you're maybe thinking about an application-specific chain where, say, you're running a game and that's the only thing you're focused on users doing on the chain, it's a lot more sustainable to onboard those users, say, from an L2 directly into an L3 than it is to onboard them from Ethereum into that L2 or the L2s that exist today, just because of cost of transactions being cheaper. And the other thing is, some teams will sponsor transactions at scale, and it's just cheaper for them to do so when they are running the chain, as opposed to having to pay transactions on a public one. So there's some interesting patterns, developing. I think one is growing user bases in crypto applications is really tough, and cost scale, exponentially sometimes. And so having more kind of control over how the chain works, how costs are managed, it makes it easier for projects to kind of grow their roadmap. And generally, the flexibility around how protocols work is something that you can only kind of start to experiment with when you are, aware of all the different components that running a chain entails. And so one way to do that is to launch it and see for yourself. Those are patterns we're seeing.
Amazing, thank you. So Matt, what do you think makes these Orbit chains very unique?
Yeah, I think, well, at a high level, blockchains are still unique in terms of database infrastructure today. So, comparing centralized databases to decentralized kind of general application layers is still something that I think makes blockchains generally a pretty unique value proposition for people who want to kind of have trustless interaction with other people. And so what's really unique about Orbit is, with Arbitrum One, with Arbitrum Nova, there are these kind of unique innovations, particularly with, the roll-up protocol with interactive fraud proofs and AnyTrust, the alternative data availability solution, that were kind of live and are live, obviously, and have growing ecosystems. But they're one chain, a general purpose, lots of applications, and kind of community run and community owned now. And what's unique about Orbit is now you can take that same technology that has kind of been battle tested in production with, billions of dollars of liquidity, millions of users, and kind of roll it yourself and make some changes to it, while being able to rely on the security that has been proven with the protocols, which is not something that, a lot of other kind of stacks have the ability to rely on. You're kind of still seeing underlying changes at the protocol level in a lot of other ecosystems. And so, for projects that are maybe more mature or want to do something unique, it's nice not to have to worry about kind of the core security model settling up to Ethereum, for example, with the rollup. You get that out of the box. And so that's a big unique value proposition. And then, we talked earlier about this, but I think there was a previous conversation on Stylus. That's something that's coming to Orbit chains. Being able to have a larger developer ecosystem that for some applications is actually incredibly more performant than the EVM is not available anywhere else. So that's something that you get as well. But yeah.
Amazing. Thank you very much, Matt. And I don't see any other questions in the chat, so I guess we can wrap this up here with Mehdi's cat on the screen. And yeah, thank you all to all of you. It was
I have something to say, so I haven't pointed it out on my talk because we didn't have time, but it would be good to discuss it here. So the other thing that is amazing about Orbits is we launch our alphas to Orbit first, so you can have access to our new features, etc. on Orbit. One of the main example here is, for example, Arbitrum Stylus, which we had a talk before that. Currently you can run your chain with the Stylus, but we don't have it on any Arbitrum chain. So this is another thing. Arbitrum chains are so agile, so you can add any new features, as I discussed, new EIPs, etc., adding native account abstraction to your chain, etc., something like that. Or other than that, whenever we add a new feature, a new thing like Stylus, you can have it on Arbitrum Orbit soon. So this is another thing that would be great to point out.
Absolutely. Thank you for adding that. And yeah, if there's nothing else to add from you guys, we can wrap this up here. And I appreciate you. It was really great. Thanks.